Theoretical recap. A vulnerability report is a structured document that communicates security findings to both technical and non-technical stakeholders. Understanding how to read and extract key information from such a report is a foundational skill for any DevSecOps specialist. A well-formed report typically contains an executive summary, high-level risk overview, a findings section, individual vulnerabilities with details, a severity rating, using scales like CVSS or qualitative labels, critical, high, medium, low, informational, a description of the attack vector and potential impact, and remediation recommendations. The most common mistake beginners make is focusing exclusively on the severity score without reading the context. A medium vulnerability in a public-facing authentication endpoint can be far more dangerous than a high vulnerability in an internal tool with no network exposure. Another frequent error is ignoring the affected component field, which maps directly to what needs to be patched in your pipeline or codebase. A useful mental model. Treat each finding as a mini-story with 4 questions. What is broken? Where is it? What can an attacker do with it? How do we fix it? If you can answer all 4 from the report entry, you have extracted the essential information. For example, a finding labeled SQL injection in API/login endpoint should tell you the vulnerability type, SCOLI, the location, /API/login, the impact, authentication bypass, data exfiltration, and the fix, parameterized queries, input validation. Workshop brief. In the previous activity, you read a fictional vulnerability report and familiarized yourself with its structure and terminology. Now it is time to go further and actively work with that material. This workshop asks you to become an analyst. Your job is not just to read the report, but to extract, organize, and interpret its key data in a way that would be immediately actionable for a development or security team. You will work with the same fictional vulnerability report introduced in the previous lesson, reading a fictional vulnerability report, structure and terminology. If you need to access it again, return to that activity. Your task is to produce a structured extraction document, a condensed, organized reference sheet, based on the full report. Think of it as the artifact you would hand to a developer who has no time to read the full report but needs to know exactly what to fix, in what order, and why. Step 1. Full reread and annotation. Begin by rereading the fictional vulnerability report in its entirety. This time, annotate it actively. Highlight or note every finding, its severity level, the affected component, the described attack vector, and the recommended remediation. Do not skip the executive summary. It often contains prioritization signals that are not repeated in the detailed findings. Pay attention to how findings are numbered or referenced, as these identifiers will be useful in your extraction document. Step 2. Build your extraction table. Create a structured table, in any format you prefer. Markdown, spreadsheet, plain text, with the following columns for each finding. Finding ID, vulnerability name, severity, as stated in the report, affected component, attack vector, brief description, business impact, what could go wrong if exploited, and recommended fix. Fill in every row for every finding in the report. If a field is not explicitly stated in the report, write not specified and note whether you think this is a gap in the report's quality. Step 3. Prioritization analysis. Once your table is complete, write a short prioritization paragraph, 150 to 300 words, explaining which 3 findings you would address first and why. Your reasoning must go beyond simply picking the highest severity scores. Consider factors such as the exposure of the affected component. Is it public-facing? The ease of exploitation described, the potential for chained attacks, can one vulnerability enable another, and the cost or complexity of the fix. Reference the OWASP top 10 categories you identified in earlier workshops where relevant and connect your choices to the CIA triad, confidentiality, integrity, availability, introduced in the quiz you completed. Step 4. Pipeline and shift left mapping. For at least 2 of the findings in the report, identify at which stage of a C/CD pipeline the vulnerability could have been detected earlier. Use the knowledge from your YAML mini pipeline workshop and the shift left lesson. For each finding, specify the pipeline stage, for example, pre-commit, SAST scan, DAST scan, dependency check, the type of tool that would catch it, for example, a SAST tool, an SCA tool, a secret scanner, and a one-sentence justification. This section demonstrates that you can connect a post-incident report back to proactive prevention, a core DevSecOps skill. Step 5. Reflection and quality assessment. Finally, write a short critical assessment, 100 to 200 words, of the fictional report itself. Is it well structured? Are there missing fields? Is the severity rating consistent? Are the remediation recommendations actionable or vague? This reflection trains you to evaluate the quality of reports you will encounter in real engagements, either as someone reading them or as someone producing them. Good analysts do not passively consume reports, they interrogate them. Submission. You have a recommended duration of 2 hours to complete this workshop. You must submit your solution before the deadline expires. Your deliverable is a single document, PDF, Markdown, or plain text, containing all 4 outputs: the extraction table, the prioritization paragraph, the pipeline mapping section, and the critical reflection. You are free to consult all previous course materials, your notes from prior activities, and any relevant internet resources, a WASP documentation, CVSS calculator, CVE databases. You may work alone or ask for help, but the prioritization reasoning and critical reflection must be your own analysis.